Who is Bernoulli? Science guy.
Science.
The science guy? I thought that was that guy.
Bill Nye.
Did he debate somebody?
Yes.
All right. So, who's Bernoulli? Austin.
Swiss scientist. Oh,
Yeah.
Isn't he in the long? Isn't he in the long line of scientists?
He is.
And he was like pushed out of the Catholic Church because of some of his beliefs. So then,
What's the grammar of this lesson? What's the grammar? Give me some grammar around. Everyone give me a piece of grammar from this lesson. All right? First come, first serve. With the hand up. No, I said with the hand up. All right, start over. All right, ready?
Wait, you can say go.
Austin,
all right.
You said
Fluid flow.
fluid flow.
Yeah.
Excellent. Fluid flow. All right. Go ahead. Caitlin.
Ideal fluid yield frictionless pipe.
That's a lot of grammar.
I'm
My head isn't that big.
ideal fluid.
Ideal fluid.
I got one. I was next.
No,
I was the main.
Okay. There's another shoe that's about to drop. Okay. So be ready. Go ahead.
Equation.
Okay. You'll love this, especially you. Yes.
Frictionless pipe.
Yes.
Frictionless pipe.
Yeah, that's
Okay. Just FL. Shorthand. All right. Abby. Development. Okay.
Kinetic energy.
Kinetic energy. Yes.
Pressure.
Pressure. Oh no.
No.
Is there another piece of that?
No,
There definitely.
yeah, there's the density.
Density. Pressure.
Frictionless.
Frictionless. Repeat. Okay. Okay.
Potential energy.
What?
Potential energy.
Potential energy. Talk to me about that, Travis. Potential energy on anything. Go. Talk to me about that. Potential energy. Hold on. Travis, you got such potential. Such
The
potential.
worst phrase ever.
Oh, you know what?
It's not
What's a person saying? I'm saying you got potential, right? Potential energy. There's hope. Isn't that neat? There's hope, potential. TNT, there's a lot of potential in that, right? PTNX and RDX, all those things. Anyway, so back to here. What's okay? So we missed one. What'd you say?
pressure.
Pressure.
I got that one.
Sounds like a song. Under pressure.
I'm gonna go with that. Non-viscous.
Okay.
That's what I said. Except
All right.
it's different word. Same meaning.
So who can tell me,
Volume.
by show of hands, what Bernoullis equation is?
Can we
By
look at
show
the
of
book?
hands?
Can we do it? No.
Yeah, by show. That means raise your hand if you can tell me what it is. Okay, Ethan. Thank you.
Pressure
Mm-hmm.
plus 1/2 the density times the volume squared plus the density times the gravity times the.
Oh, did I say that? Hold on, everybody. Let me see your eyes here. All eyes. So just from memory.
Oh.
From memory.
Memorized the.
From memory.
Remember the rooms.
That's right. Remember the rooms. Hold on.
If
There
you
was
do it real
another
fast, then I
man
think
that we
you do it.
studied, an ancient man, Archimedes. Archimedes' principle, if you remember that fateful lecture, where we integrated Archimedes with marriage.
Now.
Marriage. That's right.
together today.
It really did though, back when that.
Archimedes and marriage, Bernoulli and marriage. So we have to know what Bernoulli means before we can integrate him with. Right? Do we not? Do we not? We do. Okay. Or Bernoulli equation with the Batman movie, the Lego Batman movie.
I'm gonna see that.
Okay.
Yeah, we saw that.
Oh yeah.
So tell me.
Wonderful ways to.
Tell me the Bernoulli equation. What's Bernoulli equation say?
Like the actual thing.
Yeah, what's it say? The actual thing. Oh, you mean the words?
Like,
What?
do you want like the math? No. Or do you want the idea?
I just want to understand. You're at a family reunion.
Oh no.
Tell me about Bernoulli. A 4-year-old. A 4-year-old comes in. I want want to be a naval architect.
How do they know?
I love the Navy. I love the Navy. I love shit. Okay.
I thought you got a shirt or something.
No, I don't. It's not on a shirt or anything.
So what do you say to the person that says, you got 30-second elevator ride, tell me about Bernoulli? What's Bernoullis equation? The words. What is it?
I can't tell if it's the pressure
Yeah.
or what does flow mean.
Ooh, I got an
Good,
idea.
good.
Okay, so basically, like you have this pipe.
Hold on,
Okay,
listen.
so you have this pipe, right? Like this is a pipe.
Yeah.
And then there's water going down it at a constant speed. What it's basically saying is that the pressure and that everything is going to be constant at any point because it's like a constant flow. So basically, there's water going down there and it's all the same.
So it's pressure and not rate that it's finding.
It's
Yeah.
Or is it both?
pressure, kinetic energy, and potential energy.
Is it getting bigger?
So
Is
what's
the
the
elevator?
Can the pipe get bigger?
Well, it's like
Yeah.
it's the area of
Yes.
the pipe and elevation.
That's right.
So it's
So it has to do with flow, it has to do with energy, what goes in, it must come out, so it's law of conservation of mass, right? So he took Newton's laws, as the text states, used Newton's laws of conservation of energy and derived the Bernoulli equation. So you have, with Bernoulli, you have a pipe, right? A pipe, and what goes in must come out, right? So, hold on. Are all pipes equal?
Some are more energy than others.
Exactly. So you have a pipe here. You have a pipe. I missed that one. I missed that one. You have a pipe. Is this pipe equal to that pipe?
No.
Yeah. So one pipe
It's like
do
a-
change size.
Pan.
Oh, by the way, Navy ships have lots of pipes.
What?
That's right. Big pipes. We have this pipe, and we also have this kind of pipe. Like this. All right. So what goes in must come out. So in this particular section, those that did this particular lesson, what'd you think? I mean, there's the terms, right? You laid them out here. Right here, the Bernoulli equation, and here it is. Has to do with these terms. This is the grammar of Bernoulli. Smart guy.
I don't know.
Hold on a second. What strand?
Say yes.
What strand is this in your curriculum? So
This is math.
So what's the proposition?
It is math.
What's the proposition, challenge students, that for this particular strand? What's the proposition?
Researching.
Researching stuff to hone those research skills. Will they help you in the future?
Yes.
Yeah, will they help you figure out what's fake news and what's not? Right? How do you do that? How do you do that?
Right now, he's like, I don't know what to think about.
So, what's this term here? Pressure. What pressure?
Water pressure.
Pressure of the water.
Yeah, the water pressure here, the water pressure here, the water pressure in the pipe.
See,
What's
this
this
is
term
like very
here?
applicable to real life because a lot of the shower.
What
and
happened?
Yeah, what-
Density times volume squared.
Okay, gotta raise your hand. Everybody at once, raise your hand. A Mariah.
That's half the density times the volume squared.
Density of what?
Whatever's flowing through the pipes, I guess water, I would guess.
The liquid.
Yeah.
Right? So what's flowing, the density here, V squared. So this would be the flow rate, the kinetic energy going through. How about this right here, this term here?
Density times gravity times height.
Yeah, so what's this term? This would be the potential energy. So this is changing with the height. So look at this one. As you know, any questions here in your homework that you did, this kind of diagram here, see the height difference from this point to this point, this term would come into a factor. If it's a horizontal pipe like this, then this changes and simplifies, and that, does this apply? No, it doesn't. So it's constant. So on one side you have a point over here, these terms go here, and what's on this other side over here? What goes over here? Yes. What's that, Abby?
Oh, it's the same. The same goes on the other side.
Same goes on the other side. So on one side you have this point, on the other side you have this point. So it's like this. Right? So you notice the variation in terms. What happens, gotta raise your hand, what happens conceptually when when you go from a pipe like this to that, what happens in here? Emily? Yep.
The water slows down.
Yeah, the water slows down. It just goes
So,
open. That's right. It goes open.
and if you're tubing on a river, it's really disappointing.
Yeah, this happens here.
Yeah.
You're just like,
Yeah.
mess
Yeah, that's right. So it kind of like,
yeah. And then you sit
And-
there for like an hour.
but you know this phenomenon because you know the end of the hose on a pipe, right? On the hose, you kind of squeeze down on the end to make it go. So you knew Bernoulli at a young age, but you never gave him credit.